One of the things that strikes me funny is that a lot of people assume that the world is fair, and that we have sort of dynamics that are set up that have a lot of equality. And yet, if you look at and you study most systems in, whether it's business, academia, human beings, whatever you want to look at, we actually have a more of a learning-based system. And so a learning-based system actually has feedback loops that are built into it. And so what does that actually mean? That means traditionally that means that there's going to be, some sort of positive feedback that happens when some behavior actually happens. And sometimes you want sort of negative feedback that's going to be dampening something, but often you end up getting, you get to both sides of it depending on what's actually going on. And what that means is, I want you to give you an illustration of how this actually works, right? So in business, we think that, you win a little award and that's all you get. It's kind of like a small sort of reward, and everything's kind of sorted out from that. But in actuality, what ends up happening is that you get a reward, and then somebody in the business can actually reinvest that. So you get, let's say the reward is you get $1,000 revenue for some project that you're working on. Well, then you could take that $1,000 and reinvest it within the firm. And then you do that again, and you do that again, and you do that again repeatedly. And so at the end of it, and I always show this simulation, it's actually quite easy to do. I show the simulation where, quite random effects, just really random effects can drive these enormous differences over the long run, where, for no reason at all, a firm could be dramatically, have dramatically a lot higher resources or, performance than something else. And this happens in almost in almost any environment, where you have this sort of repeated feedback system. In fact, it's really hard to sort of measure the stock market because there's a sort of repeated feedback system that happens in it. So it's tricky, and we have to look for all sorts of ways to measure price and all that kind of stuff, and look at returns instead, and look at different ways. It's very tricky because you have that sort of repeated feedback that happens, and we assume that this doesn't exist. And it's rather unfortunate to assume that doesn't exist, and that everything is sort of fair within the environment, but because it's essentially not a lot of times, because you can have some sort of random endowment at the beginning, and I sort of illustrate this again, just sort of coming back to the simulation, and you can look this up. It's a poly-earn problem, and you can have a random endowment at the beginning. Somebody is slightly bigger, somebody is slightly smaller, somebody is a little bit more intelligent, a little less intelligent, or they grow up in a certain household compared to another. And these effects, they compound over time. And in fact, that's why we get, we look at compound interest. And anybody that, in the context of the stock market, if I said compound interest, everybody understands what it is. We have this sort of, this miracle of compound interest where things grow exponentially over time. But the same effects happen in all dynamics, in everything in life. And so one would expect that small perturbations at the beginning can have enormous effects later on. And frankly, it's somewhat unfair with the system that has that, and we have to design, have sort of, I don't know how to say this sort of politely. I'm sort of, I don't want to be sort of misquoted or anything like that, but we have to design systems, or we have to think about how do we make sure that it's sort of resetting itself so we don't have these enormous differences over time. And frankly, there's not a lot that we currently do at this moment to reset some of these things. We do have taxation, for example, does sort of compensate for some of these effects over time. We have things like, people just being wasteful with the resources that they're given, and sort of normal human behavior and all those kind of things that happen. But there are long-run trends that happen, especially in capitalist societies, where there are these inheritances that happen. In fact, it's not just capitalist society, it's society in general, right? Like, this is a long time. It's been going on for thousands of years. This is human beings. And this is true in a lot of different dynamics, a lot of different systems. But we have to be careful if we're to design systems to make sure that we have equitable, if we want to make sure that everybody has opportunities and we're sort of fully maximizing the full potential of everybody without, the effects of randomness or random perturbations, that's what's going on, or sort of, just happenstance. We have to be careful, and we have to think about ways to mitigate some of these problems in the long run, because the issue is not whether we're equitable or moral or anything like that, which is those are very just sort of viewpoints, but the issue is that if we want to exploit opportunities that are in the market, and we want to make sure that we're getting maximum amount of information about the marketplace, and we are fully exploiting all of our resources completely that we have available to us. And I know that sounds like a bad sort of term, but that's what we sort of talk about in business. Business research, where we're talking about sort of exploiting resources, and it's just basically, we're talking about like fully utilizing, making sure that everybody is met to their complete potential. You're fulfilling your desires, I guess is a better term to think about it. And so, we have to think about that, of how do we create systems to ensure that are self-correcting and that are fair and equitable, to ensure that everybody can have the fullest potential that they possibly can get. And that's where we have to think about the fitness or the performance of the entire system, in making sure that we're sort of maximizing on system performance of the thing that we're looking at. So the system performance would be everything accounted for. What does that actually look like? The sort of, if you've got, so for example, in the business context, you got 100 firms, you want to look at the performance of the 100 firms together, the 100 companies together,